Okay, here's a Leviton 583 three-way switch that was taken out of a Rembrandt lamp. There's three wires, a hot wire and a wire leading to a single bulb and another wire leading to a double bulb. As the rotor or the knob is turned here, the switch makes a different combination of connections that I'll explain in a moment. This is an illustration of the lamp circuit with the Leviton 583. The internals have three metal fingers that contact a central rotor. The rotor has copper around three of its four sides, and the fourth side is just plain old plastic. So as that rotor turns, it makes different combinations of contact. So initially, the rotor is in a position where the copper forms sort of a backward C. So the 120 volts AC is not being fed to any of the lamps. Now when the rotor is turned clockwise by 90 degrees, the copper on the rotor forms sort of a U. So now you have a continuous circuit from the 120 volts AC to the single lamp via the red wire. And now when the rotor is rotated once more to form a C shape, then the 120 volts AC is fed to the blue wire, but not the red wire. So the two lamps on the blue circuit come on. And then when the rotor is rotated once more, it forms a upside down U, which then brings both the red and the blue circuits in contact with the 120 volt AC, and all three lamps come on. And when you turn the rotor once more, it returns to the original position where neither the blue circuit or the red circuit are in contact with the 120 volts AC. Chances are that in the fix-it clinic you will never repair such a switch. I tried with this particular one and only got mediocre results, largely because it's quite old and the fingers were rather worn. Typically what you would do is replace the switch with a new switch. But that said, it's still useful to understand how these switches work so that you have a clear picture in your mind of what is actually going on in terms of the mechanisms you're working on when it comes to lamps. Alrighty, see you next time.